Man, somebody also broke into my house and left all the doors open. Seriously, who does that to an advent calendar? Anyway, sorry about the follow-up dad joke, but in this video, Algebros, we are going to put that step-by-step process for analyzing a rational function in order to sketch the graph of this particular rational function. So let's go ahead and begin. The first thing that you want to do is factor the top and bottom polynomials, and notice that each of those do. In the numerator, that polynomial is going to factor as x plus 1 times x minus 3, and in the bottom we have a difference of two squares, and it would factor as x plus 2 times x minus 2. So this is the factored form version of the rational function, and I like to consider the original form like the standard form version of the rational function. Now notice that none of the factors on top match the factors on bottom, so this rational function does not reduce. And what that would mean is that there's no hole in the rational function graph. So at the very bottom of this page, you'll see that there's sort of this laundry list of items that we will be filling out throughout this example. And once we have all this stuff filled out, we'll see what we can translate into the coordinate plane. But for now, what we can say is that, in terms of a hole, there is none. So we'll move on to finding vertical asymptotes, and I'll make a little workspace for that. In order to find the vertical asymptotes, we take the denominator of the rational function and we set it equal to 0. I recommend using the factored form version of the denominator. So we would have x plus 2 times x minus 2 equals 0. And we know what to do here. We can just set each factor equal to 0 to solve for x. So there are going to be two vertical asymptotes. One's at -2 and one's at +2. So in our laundry list here, we'll have for VAs x equals -2 and x equals +2. This will actually help us get the domain now. The domain is going to be the set of all x such that x does not equal -2 and x does not equal +2. And the reasoning behind that is because the values of -2 and +2 create division by 0. So in terms of domain, those are bad x values, but in terms of vertical asymptotes, they're good for us because they tell us where they'll be in the graph. So let's talk about any horizontal asymptote. When you go to find the horizontal asymptote, if any, you want to compare the degrees of the two polynomials, and I recommend doing that when each of those is in standard form. So if you look at the degree of the numerator, that degree is equal to 2, and the degree of the denominator is also equal to 2. So this is a situation where n equals m, and that would land us in case 2, where we have to form the ratio of leading coefficients. Now the leading coefficient of the top polynomial is 1, and the leading coefficient of the bottom polynomial is 1. So that ratio is going to look like 1 over 1, and of course that simplifies to just a single solid 1. So our horizontal asymptote will have the equation y equals 1. Now, since you can only land in one of those three cases, that would mean that there's no oblique asymptote, so I'm going to put none for that. Alright, so if there were a workspace for oblique asymptote, all we would be able to do is just say that there is none. Let's talk x-intercepts next. In order to find the x-intercepts, we're going to set the numerator equal to 0. And I recommend using the factored form version of the numerator. So we'll have x plus 4 times x minus 3 equaling 0. And we'll get two answers for x here, meaning there are two x-intercepts. One's at -4 and one's at +3. So I'd like to write these out as ordered pairs so that we don't confuse them with vertical asymptotes. So -4, 0, and 3, comma 0. For a y-intercept, what we're going to do is plug 0 into the function. And this one I actually prefer to use the standard form version for. The arithmetic tends to be a little easier for some reason. So it would be 0 squared plus 0 minus 12 on top. And then on bottom, it's going to be 0 squared minus 4. And all of these zeros will go away. And you'll have negative 12 over negative 4, which reduces to positive 3. So there's a y-intercept at 0, 3. Alright, so that's it for the laundry list of things that we can infer by hand. Now we're going to transfer as much of this information as possible into the coordinate plane. So there's no hole to plot, so there's not going to be an open circle that we have to plot in our graph. But there are two vertical asymptotes. The first vertical asymptote crosses the x-axis at negative 2. And I'll write its equation down below. And then the second vertical asymptote crosses the x-axis at x equals positive 2. I'll write its equation below as well. The horizontal asymptote is going to cross the y-axis at y equals 1. So I'm going to put a horizontal dashed line going through that y-axis tick mark. And here's its equation, y equals 1. There's an x-intercept at negative 4, 0, an x-intercept at 3, comma 0, and then a y-intercept at 0, 3. And that's about as much as we can do in terms of transferring this information into a pictorial setting. So it looks like there are going to be 3 different pieces to this rational functions graph. And at this point, it's somewhat ambiguous. So in order to pinpoint exactly what the 3 branches would be doing, we would have to maybe defer to our graphing calculator, which I'll pull up on the screen in just a second. But I do want to let you know in advance that this is what I'll be entering into y1. I'll be using the standard form version of the rational function, and the numerator is going to be in parentheses, and then the denominator is also going to be in parentheses. Alright, make sure that you use those parentheses, otherwise your graphing calculator is going to give you a graph that looks different than if you were to use the parentheses. Okay, so here's my graphing calculator. In y1, parentheses x squared plus x minus 12. Close off the parentheses, hit the divide key so that in the spirit of Guns N' Roses you get the slash symbol on there. Parentheses x squared minus 4. And then since I have a TI-84, I'm going to hit zoom 6. For those of you that have a TI-83, you maybe want to press zoom option 4. And there we have the graph of our rational function, which clearly indicates that there are 3 different pieces to it. And you'll notice that like the ends of these 3 pieces either flatten out horizontally or sort of flatten out in a vertical perspective. And where these ends of these pieces are flattening out are exactly where our asymptotes are at. So with that said, I'm going to go back to the notes here and draw out these 3 branches as best as I can. So the first branch, the one furthest to the left, if we were to maybe base things on the x-intercept and maybe head left, you would see that that branch is heading towards this horizontal asymptote, heading to the left or towards negative infinity on the x-axis. Whereas if you were to go to the right of this x-intercept, the graph would be bending its way towards the vertical asymptote while getting closer and closer to it, but never crossing or touching it. Alright, because remember, you can never have your graph crossing or touching a vertical asymptote. For the middle piece, if we base things on the y-intercept and go to the left of it, what we saw was, sort of like one half of that graph sort of taken on the form of a vertical line. What's really happening is that this piece of the graph is getting closer and closer to the x equals -2 asymptote without ever crossing or touching it. And then, the other part of that is heading up to the vertical asymptote of x equals +2 without crossing or touching it, but still getting closer and closer to it. As for the third piece, if you base things on the x-intercept and head to the left of it, part of that piece goes close to the vertical asymptote of x equals 2, and then the rest of that piece approaches the horizontal asymptote of y equals 1, and that would be a legitimate sketch of this rational function. And that's where the fun and excitement for this example ends, and also the video. So if you guys have any questions about anything that I went over in it, feel free to let me know. Otherwise, thanks for watching, and I will catch you guys in the next one. Take care.